All right, as we start day 12 here, we have a new chapter, a new unit. So we're going to start here with 6.1. All right, so we're going to be looking at polygons today, equilateral polygons, equiangular polygons, and regular polygons. So theorem 6.1, right out of the gate, the polygon angle sum theorem. So the sum of the measures of the interior angles of an n-gon. And n-gon just means however many sides is the polygon. So we don't have to be specific in its name, like octagon, we can just say an n-gon is 180 times n minus 2. So S equals. So n is the number of sides. S is the sum. So with these little questions, just make sure you understand what is given and what is being asked of us. So they're telling us it's a heptagon, so that means n equals 7, and they want to know what is the sum. So S equals 180 times 7 minus 2. So that 7 minus 2 is 5, so that's 180 times 5, which is 900. So the interior angles of a heptagon add up to 900. So we're going to try this again, but it's going to be backwards. This time we know that n is 17. They want to know what is S. So S equals 180 times I don't know why I was thinking that one was going to be backwards. 17 minus 2. So the only difference here is notice they gave us an actual vocab word. Here they kind of just put it right in front of our face. So 17 minus 2 is 15. 15 times 180. S equals 2,700 degrees. All right, we have some vocab down below. An equilateral polygon. Polygon with all sides congruent. Equiangular polygon. Polygon with all angles congruent. And then a regular polygon is a combination of the both. It's a polygon that is both equilateral and equiangular. All right, corollary to the polygon angles sum theorem. the measure of each interior angle of a regular n-gon, and it's regular because they're all going to be the same exact thing, is 180 times n minus 2, so that's going to give us all of the interior angles, and we're just going to divide it by how many angles there are. So that's just for one singular angle. So the numerator here is all of the interior angles divided by how many there are. You get the sum. You get the measurement for each individual interior angle. All right, practice problem number 2. The common housefly, I'm not going to try and attempt that word, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? So they keep telling us hexagonal. That means that n equals 6 for a hexagon. So 180 times 6 minus 2 divided by 6. So that's 180 times 4, which is 720. So 720 is all the interior angles added up, divided by 6. Since they're all congruent, that gives us 120 degrees apiece. Try that again. This time we're going to do it with a nonagon. So the sides would be 9. So that's 180 times 9 minus 2 divided by 9. 9 minus 2 is 7, so 180 times 7 divided by 9 is 140. All right, what is the measure of angle y in the pentagon TODAY, or today? How clever. So since it's a pentagon, it's not a regular pentagon, or they would all be congruent, and we can see that they're not. So that means n equals 5. So S equals 180 times 5 minus 2. So that's 540 degrees. So we know theorem 311, triangles add up to 180. Supplementary angles add up to 180. So we're always used to subtracting things away from 180. So now this is just an opportunity for us to use something else other than 180, because now we know a pentagon is 540, quadrilateral would be 360, and so on and so on. So 540, I'm going to take away the 90. I'm going to take away the 120. I'm going to take away the 150. I'm going to take away the 110. And that's going to give me $70. So the measure of angle y equals 70 degrees. All right. So here's just another one. Try it again. This time we have a quadrilateral. So n equals 4. So S equals 180 times 4 minus 2, so 360 degrees, and 120.85, I'm guessing here 53. So 360 minus 120 minus 85 minus 53, which is 102. All right, theorem 6.2. This is going to be the sum of the exterior angles. Okay, theorem 6.1 was the interior angles. So the sum of the measures of the exterior angles of a polygon, there's one at each vertex, is 360 degrees. So exterior angle, exterior angle, exterior angle. I'm going to come back around with another color here. Maybe those colors look confusing. I don't want 1 and 4 to look special there. 1, 2, 3, 4, 5. So 5 sides, 5 vertices. Each vertice has an exterior angle. Yes, we can go out the other direction if we wanted to. Meaning if I was to take all 5 of those blue angles and make them adjacent to each other, they would make a full circle. So measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 should all equal up to 360 degrees. So what is the measure of angle 1 in the regular octagon? So since it's regular, okay, that tells us that each of the interior angles is going to be the same exact thing. Okay. And if those are going to be supplementary, that means 5 is going to be the same thing as 6, which is going to be the same thing as 7, same thing as 8, same thing as 1, same thing as 2, same thing as 3, same thing as 4. Meaning all the exterior angles are going to be congruent as well. So no formula needed for this. It's always going to be 360 divided by however many exterior angles there are. In this case, there's 8. So 360 divided by 8, we have 45 degrees. So a little bit easier than the interior angles because it's always 360. Interior, it's going to change depending on how many sides we have. So we have a nonagon, so that is n equals 9. So that's just 360 divided by 9 exterior angles, which is 40 degrees. All right, check out that homework here at the bottom. Don't forget about the exit ticket. Make sure you contact me with any questions. Office hours are available. Contact me if you need any one-on-one time. Make sure you're getting these homework problems checked because you will have a homework quiz in the near future.